All right, good afternoon. That was a good lunch. Looks like a good lunch. I had some too as well. So, okay. So, obviously, I prepared many structures to show you, as you see in your folders. For each topic, I have a few PDB files you can look at, but unfortunately, we didn't have time to go through them. But I think it's okay. You learn the tools, not to look at them. So if you're interested in the topic, you can look at them yourself as well. And then today, for the next hour or so, I don't want to stand in the way of your test. So we'll go through a couple examples. Let's see how many we can go in an hour or so. Look at a couple of structures to sort of give you a feeling how we do this. Okay? So this is not a tutorial anymore. So first we'll look at protein kinases. So if you look at the protein kinase folder, there should be files there. Do you see them in your folder? Protein kinases? Yes? Okay. So we're going to look at P38, that one I talked about this morning, the conformational DFG in, DFG out. Okay, we'll look at that. Okay? So we only need 2 files. The rest you can ignore for now. These 2 files at the bottom. So let's open the first one, the one with the SKB compound. Do you see it? So So we open it, high waters. And you can see this is the canonical view for a protein kinase. Large lobe at the bottom, small lobe at the top. Okay, the compound's right here. The one right there. Actually, another one on the surface, which is the crystal packing. So that's why I didn't show that. You see something similar? Yes? The P38 SKB. Got it? Open it. Open it, high waters, and then make it sort of the canonical kinase conformation. Well, to look at it, so essentially the compound's right there. So to make sure the compound stand out, maybe we'll give it a different color. So click on the compound, and then color by element. Let's make it pinkish, like that. Okay? Still good? All right. And we can also save the view of this if you want. Well, let's save it just in case. So view v1 store. Okay? So now let's open the other file. The second structure, so go to File, Open. And that will be the one at the bottom. Oh. So P38 DFG out. So P38 still, but then it's called DFG out. Do you have that? Okay, click on that. Say open. So you can see they are very similar overall, but they are still a little bit different. So first we do align the 2 structures so that we make sure that there is no systematic difference between them. So to align the 2 structure, just go to A. For the DFGL structure, they say align, and then align to SKB. So you can see a small little change. And oh, by the way, you can also see the RMSD from the text window as well, if you're interested in looking at that. So now we have the 2 structures. The SKB structure green and the purple, And then this is the compound for the DFG out, so we'll give a different color as well. So click on that. And so go to selected, color by element, and we'll make it orange. Oh, that's too dark, sorry. So I'll make it a different color. Yellow, let's make it yellow, make it brighter. So now you can see the two compounds, okay? You can also see, okay, so now we have it, so we can zoom in if you want. So you can center on the compound, middle click, center on the compound, and zoom in. So you can already see the difference here. So green is the structure bound to the SKP compounds, goes here, and then cyan, the structure bound to this compound, goes there. So it's a different conformation. Already you can see that, right? Everybody sort of on the same page? All right, good. So this also reminds me there are a few waters here, which let's just hide the water on that structure too. So, okay, so now it's cleaner. So now we have basically two structures in two different states. So we can morph between them, as I showed you yesterday, but you didn't have a chance to do it yourself. Now, have at it, do it yourself. So let's morph between the two structures. Okay, so okay, are we all sort of in the same? Okay, so morph. Plug in, morphing, and then we're morphing from the SKB structure to the DFGL structure. So state 1 is SKB structure, and then the end conformation is the DFGL structure. And then we'll do 60 frames just to make it slow down a little bit. And we're going to use linear interpolation. And that's basically all the things you need. So you see what the input, you had similar things. You can go to 100 if you want. I mean, this is actually very fast, so calculation is very fast. Let's do 100. So the movie is slower, so it's easier for you to see. Okay, got it? All right, when you're ready, just say morph. And then you need to do calculations. You need to make a movie 100 frames. So you need to morph between the two structures in 100 steps. So once it's done, a new object shows up called morph01, 100 steps, 100 frames. Do you see that on yours? Yeah? Do you see it on yours? Nope, already? Got it? So are we all together?
Yes. Can you repeat the step again?
Huh?
Can you repeat the step again?
So under plugin, so let's start from beginning again. So you have the two structures lined up here, colored the same way. Under plugin, under plugin, there's a morphing command. Click on that. This window opens, and then set to the 100 frames. Use linear interpolation, and then click on morph. It should give you something right there with 100 frames. Also with a play button down below. Okay? So when you have it, just click on play, see what happens. So you can clearly see the configuration change. Well, please remember, this is computerly made up. Okay? This is done by a computer. So It's very helpful to understand the change, but that's not how it happens. So don't think that this is how the protein changed from there to there. In the middle, who knows what happened, but anyway. But it's helpful for you to sort of see the change. And because the change here is small, so it's not as impressive. So we can zoom in a little bit. You can see the change better from this state to that state. Okay? Do you sort of see the same thing? Yes? Okay, so far I've shown you morphing using only the ribbon or cartoon drawing, but you can be more sophisticated. You can morph side chains as well. Because in this case, we know this is the phenylalanine that goes back and forth. So we'd like to show that phenylalanine side chain, right? That will be even more informative. So let's do that. So stop the morphing, stop the movie, and then you can delete it. Go to A, delete object. So you can delete that morph. Let's do a better job. Okay? So now it's gone. Can you do the same thing? Okay? So now we know this is the phenylalanine. So that's the screen, the end of the screen structure is phenylalanine. So let's click on it. You see it is the phenylalanine. So we show that at sticks. You see something similar? And you can clearly see the phenylalanine side chain is clashing exactly with the T-butyl group, right? So the inhibitors utilize the phenylalanine binding pocket. You see the same thing? Okay, so that's the phenylalanine in the DFG state. The phenylalanine in the DFG state is right here. That's the glycine. So click on here, you get the phenylalanine in the DFGL state. You see it's phenylalanine. It tells you down below as well. So we show that as sticks. Okay, so now we have two states with two side chains shown now. Okay? So now we can morph again. We can morph between the two states. You can now see the phenylalanine side chain change as well. Okay, so let's go back to morph again. Same thing, 100 frames, linear interpolation, and morph. It takes a little bit of calculation. Okay, it's done. So now if you zoom in and look at it, so now if you play, so you see the phenylalanine side chain move as well, right? So in here is clashing against this compound. Over there is clashing against the Sims-Klein compound, or where ATP is. So ATP binding is not possible. Over here, the compound binding is not possible. Do you see something similar? Yes? Huh? What?
Please repeat this
Uh-huh.
from the side chains.
Yeah, show the side chain is more informative, right? You can also show the aspartate ahead of it, the DFG, the DF, but then that'll get a little bit more complicated. So you have to have a compromise between getting it across versus showing all the information you want. Sometimes it's more important to make sure that people understand what you're trying to say than tell them the entire story. Okay, so are we all okay with this? You all got it? No? Okay. Speak up, please. If you're not okay, speak up.
How to make a 2D structure of this end?
Huh? So just show the sticks. Show them as sticks.
Yes, and then
Yeah. Click on that, and there should be select. Under select, show sticks. Sticks.
sticks.
Yeah. Now it should show up, right? Right there. And then do the same thing for the other side. Now you can morph between them.
And go to cell and stick. Same.
Yeah. And then you morph, and then they'll change back and forth. Try it. Do the morph and see what happens. So, sorry, I need to. Everybody else is okay back here? You okay?
I went to stick and it is all filled up.
Right. Oh, no. You had to select first. So select this phenylalanine first. No, that's not select. So select the phenylalanine. Where is the phenylalanine? Right here. No, that's not. That's the compound. Well, the worst turn on the sequence. So turn on, click on S.
Click on
Sec. Yeah. Yeah, sec. SEQ. Yeah. And then up here, you can go to phenylalanine. That's, what number is it? I forgot the number now. DFG. Do you remember what number it is? Oops, my apologies. You have it? Let me see. So, right here. So that's the phenylalanine right here.
this one.
Click on that. Oh, I'm clicking the wrong way. So, no. So how do you do clicking on this? Keep on the trackpad. No.
This is how it is getting.
Huh?
This is on the way.
I see. So it's not doing the right thing. So it should tell you what residue number that is. So let me go find out. Do you know what the residue number of the phenylalanine is? Can you click on the phenylalanine? What's the residue number? 169? Huh? 168. So go to 168 up here.
169.
Huh?
169.
169, right? That's what I remember. So 169 up here. Scroll down. There's a scroll bar down below. So 169. Do you see 169?
There is no 169.
No. 166 is, yeah.
166 and
No. That's 166, right? So that 166 is under the 1. So it count to 169. That should be a phenylalanine. Click on the phenylalanine. Do you see it? No. Click on the sequence. Do you see a phenylalanine? Yeah. There you go. You have selected it. And now show as sticks. Yeah. And then do the same for the other sequence. The one above it. There's a phenylalanine above it. Do the same. Yeah, there you go. Now you can morph back and forth. Yeah, I don't know about the trackpad, what happened there. Okay, all right. So everybody else good, right? Okay, so that was useful. Showing a side chain is helpful, right? So now let's go one step beyond that. Since you're better at it now, let's be even more challenging. So let's kill this morph again. We don't need it. So let's delete it. We're going to morph again. But this time, we're going to morph surfaces. Okay? We show both structures as surfaces. Okay? So go by the first structure, say show surface. Second one, show surface. You had two surfaces now. And then we morph again. So go back to morphing. This actually is going to look even better. Since this is pretty heavy duty calculation, I'll do only 60 frames. Otherwise, we could be here for a while. So you want to give it a try? So just do that, say morph. And then let it calculate. It's going to take a little while. That's why I only asked for 60 frames. Otherwise, it'll take even longer. Okay, it did it. Okay, so now you have a morphing thing go between the two surfaces. So you start a movie. Everybody has it or similar? Good. Thank you. Good? Good? Okay. How about back there? You're good? Got it? Okay, so now start the movie. And it looks horrible, right? It doesn't look good. Yeah, front is, doesn't look good. So now we're gonna hide the surface that's stationary, that doesn't change. Let's go there, hide them, okay? Now, what does it look like? Does it look better? I mean, I zoom in a little bit, hide the surface for these original structures, only use the morph surface. You can see at the beginning, there's something sitting in here. That's a phenylalanine that's blocking the compound. And then that got out of the way, now you have a pocket here for the compound to bind. And then at the beginning, this compound is available, but then once you morph it over, it clashes over there. You see that? So this just gives you a sense, a lot of things you can do with the morphing business. And this is very rudimentary still, very rough. If you're going to show really that in your talk or your presentation somewhere, you probably will spend a little bit more time, plan your movie a little bit more, plan your construction, this and that. But it certainly tells you that you can do a lot of things with this morphing business back and forth to show confidential changes. Okay? So you see similar things? Okay. So, whoa. Okay, about half hour, not too bad. All right, so I guess we're moving on to, so we're done with this one, I think. We have a rough understanding of this DFGL conformation, the phenylalanine going out of the way. And that's this is DFG in, and that's DFG out. So and then you see this red thing? That's a Sparty side chain. So you can see that side chain moving back and forth as well, right? So that information actually is there. That's a Sparty side chain. So that's flip-flopping during the transition as well. Okay, so good? All right, so we're done with this story. All right, so the next story I want to show you is related to herbicides. The one I showed you, again, confidential change in the herbicide binding. Unless you have something you're more interested in, we can go there. Otherwise, you go where I go. Okay, herbicides. Okay, so that's in the folder for fatty acid metabolism.